I'm going to illustrate model data simulations with a beta prior. Let's return to our example where we're going to do a survey of 20 Americans, and we're going to ask what is your favorite sport? And we're interested in the fraction of Americans who say football. Now here we're going to use a continuous prior, and my best guess at this fraction is 20%. And let's suppose that my guess is worth about 50 observations. So I'll be using a beta prior with shape parameters 10 and 40. And there's a picture of my prior. Now, here's my model then. We'll be sampling 20 people, and the number of football lovers, y, is binomial with probability of success p, and my prior for p is beta with parameters 10 and 40. And there I've written the expression for the joint density. Now, let's suppose we're interested in predicting the number of football lovers in a future sample of 20. We can compute the predictive density by taking the joint density and integrating out p, but it turns out that that gives us a relatively awkward formula, so it's easier to compute the predictive density by simulation. So what we'll do is on StatCrunch is we will simulate values of p for my beta prior, and for each value of p I'm going to simulate binomial values y for my that have 20 trials and success probability p. And I can, by summarizing the values of y, I can learn about the predictive density. So let's go to StatCrunch, and we're going to start off by simulating from a beta density. So I go simulate from a beta density, and my parameters are 10 and 40. I'm sorry, first I want to simulate 1,000 values, sorry. And my parameters are 10 and 40. And I'll call that column P. And next, so those the values in P1 represent values from my beta prior. And next what I'll do is I'll go to compute expression, and then I'll compute expression. I want to simulate a random binomial. I'm going to do 1,000 values where I have the sample size is 20 and the probability of success is P1, and I'll call that Y. Okay, so the values in Y are simulated from the predictive density. So if I want to learn about the probability of different values, what I can do is I can go to the my tables and do a frequency table of the values of Y. And so it tells me, for example, the probability of observing y equals 0 is around 0.03. The probability of 1 is 0.075, etc.